This short playlist contains a couple videos where I go over using Venn diagrams to evaluate the validity or invalidity of categorical syllogisms for the Aristotelian and Boolean interpretations of categorical logic. So let's say we have a syllogism like this. All dogs are animals. All dogs are mammals. Some mammals are animals. The first thing we're going to do again is we're going to make a premise diagram. We're going to make a conclusion diagram. So here's our premise diagram. We mark it as a premise diagram. The Middler-Bridging term, the term that is in both premises, we use a capitalized letter from a significant word for that Middler-Bridging term. It always goes up top here. Our minor term, the subject of the conclusion, also in the minor premise, that goes in the bottom left here. Finally, our predicate term, which is a term in our first premise, and the predicate of our conclusion, the major term, it goes in the bottom left corner. Major, minor, Middler-Bridging. Middler-Bridging, major, minor. We do the same thing for our conclusion diagram. So two diagrams, one for the premises, one for the conclusion. So when we want to evaluate our arguments, we start off in the Boolean interpretation, just as with direct inferences. Now we've got three circles, so we want to be a little careful in how we fill our diagrams in. We always start with our universal premises first. Since both our premises in this particular argument are universal premises, it doesn't matter which one we start with. So all dogs are animals. Again, we're being good Booleans. We don't know if there are any dogs. We don't know if there's anything in that D circle. We don't know if there are any animals. We don't know if there's anything in the A circle. But what we do know is everything that's a dog is also an animal, if anything is. So everything in D would also have to be in A. And that means if our universal affirmative statement is true, this area here, D and only D, that would have to be empty because everything in D is also in A. So we'll shade that area in. That indicates that that area has to be empty if our premise is true. Always shade for universals. Always do our universal premises first. Both premises go on the premise diagram. So we'll go to our next premise. All dogs are mammals. Again, we don't know if there are any dogs. We don't know if there are any mammals. But what we do know is everything that's in that D circle, everything in D, also in M, also in that M circle. And so that means everything in D that is outside of M, those areas have to be empty if that second premise, the minor premise, is true. So we'll shade those areas in again, and that will be, at minimum, how the world has to be in order for both of our premises to be true. Now we go over to our conclusion diagram. Our conclusion says some mammals are animals. Some is a particular statement. We understand that as there's at least one, that means we're going to use an X. So we say there's at least one thing, call it X. It's in our mammal circle. It is also, because it's a particular affirmative, in our animal circle. So it's got to go somewhere in this intersection here. It's got to be in the part of our Venn diagram that is in both M and A. Now, because we have three circles, there are two different areas in that intersection. One of them is just in the M and A circle. It says there's at least one thing, if we were to put the X there, that is an M and an A and is not a D. Up here, this says there's at least one thing. If we put our x here, it's an M, it's a D, and it's an A. Okay? So if we put it up here, that includes all that information. We put it down here, that includes all that information. Our conclusion doesn't have any of that. It doesn't tell us whether that mammal is an animal and a dog or an animal and not a dog. So either one of these would make our conclusion true. It doesn't dictate which one. So we put an X in and we put it on the line here between those two areas. It has to go inside here. Got to be in there. But it could go here, it could go here. Nothing definitive in our conclusion. Either way would make our premise true. So now we look at our conclusion diagram. I need an X somewhere in here. Either place or both would make my conclusion true. I look over in that area on my premise diagram, and there is nothing that is definitive here. Nothing about making these two premises true commits me in any way to what has to be true for these things. And so it's possible for my premise to be true, namely if these areas are empty and nothing else, and my conclusion isn't guaranteed to be true then. So that argument is invalid in Boolean logic. So we write invalid Boolean logic. Every time we're invalid in Boolean, we want to test it for Aristotelian. Just as before, we don't have to worry about that conclusion diagram, don't have to change it at all. Only have to worry about our premise diagram. Premise diagram, that modification is now slightly more complicated because we'll want to check for the Aristotelian assumption in every single circle. So the way that we'll do this now, we'll go to our premise diagram and we'll look at each circle. So let's start with M here. And we'll say, does it have a member already? No, it does not. Okay. Is there one and only one place it could go? No. It could go here, it could go here, it could go here. Nothing about making my premises true tells me anything about what's in any of these areas. So my Aristotelian assumption, it doesn't tell me where my X should go specifically. And because it doesn't tell me where it should go specifically, I don't add it. And by tells me where it goes, I mean there's only one place on that circle where it could go. In our M circle, there are 3 places, so I don't add an X. Let's go over here, look at our A circle. Again, no X's here, but can go here, it can go here, and it can go here. So there's more than one place where that X could go, so my Aristotelian assumption doesn't tell me where it should go. If I put it here, well then that tells me more about that thing than the Aristotelian assumption does. Aristotelian assumption says there's got to be something in A. If I put it here, I said there's got to be something in A, and it's an A and nothing else. That's not part of my Aristotelian assumption, and that's why I can't add an X here. Same reason I can't add an X here or here. Only in a circle where I've got one and only one place where I can put my X do I add my X. This brings us to D. No X's in D. It can't go here, that's shaded. It can't go here, that's shaded. And it can't go here, that's shaded. So if D has a member, there's only one place it can go, in this intersection here. And so, because there's only one place where it can go, I add it to that circle. I circle it to remind myself that's only information that's true about the world if that's a good Aristotelian class. And now I go back and I evaluate my relationship between what I need to make my conclusion true and what I get when my premises are true. So I need an X somewhere in this intersection to make my conclusion true, and anywhere will make it true. Now I look at that area and I say, oh, now I've got an X there. However, it's a circled X, so before I say it's valid in Aristotelian logic, before I say that making these premises true will guarantee the conclusion is true, I have to check and see if the circle I put that X in is a good Aristotelian class. Since I have a verbal or an English categorical syllogism, I can look at my subject class here, that middle abridging term, and I can see that it's dogs. Dogs have at least one member, so that's a perfectly good Aristotelian class. So if I make my premises true under the Aristotelian assumption, these things have to be true. The X being here has to be the case. That's all I need to make my conclusion true. And so I say my argument is valid in Aristotelian logic. Now, let's take a look at another example.